Student, hope everything is going well and welcome to Vidyanest. Today our topic of discussion is vector. Vector is important for board and joint. Irrespective of any board, you see if you culture the question, 2-3 questions you can expect even in JEE main and advance. Okay. Again, vector has strong what I can say connection with physics. Now we will pursue the chapter vector. I will try to give you a little bit of deep little bit of depth in vector. Let's see. Vector is what? From junior class you are taught the definition of vector. Vector is a quantity which has magnitude and direction like this. Suppose you are moving from A to B. So what is its magnitude? Its magnitude is AB. And direction, this is the initial position, this is the final position, it displaced from A to B. Understand? So this is the direction. Direction the displacement from A to B. Now, this magnitude and direction combinedly give you the definition of vector. So, AB means it moves from A to B. So, if you reverse the arrow sign, means if you reverse the direction, it will become B to A. The question is, will there be any change in that? If I revert the direction, yes, I can put a minus sign. See, if I change the direction, then I can put a minus sign. And see, in this case, vector displacement is 0. That is called zero vector. Zero vector. Vector displacement is 0. Now, this vector, along this vector, there will be a scalar value also. That means from A to B, once you are moving, that means how much displacement takes place? Magnitude AB. So magnitude AB, once you get magnitude AB, that means what will be the direction? It moves from A to B. Now the question is, can I put equal to sign? No, because this is a scalar value, only magnitude. But once it displaces from A to B, that means we have the direction from A to B. So put one equivalent sign. So this unit displacement is equal to the movement from A to B. So 1 unit displacement will be vector AB by its magnitude. So this thing is called unit vector, unit vector. So what conclusion I can draw in unit vector? Therefore, unit vector is any vector by its magnitude. Okay. So this derivation, this definition is inherited from that concept. That means displacement from A and B means the point, one point which has initial position A moves to B. So that unit displacement is equal to movement of AB from A to B. So one unit displacement by unitary method, AB by magnitude of AB. So a vector, if divided by its magnitude, then it is called unit vector. Understand? Unit vector. What will be the length of unit vector? What will be the magnitude of unit vector? See, let us take its magnitude. Okay. See, the numerator, that vector's magnitude is magnitude A itself by magnitude A. That is 1. Okay. So unit vector's magnitude is also always 1. Therefore, from this example, one conclusion I can draw that the vector whose magnitude is 1 is called unit vector. If the vector whose magnitude is 1 is called unit vector. Okay. So that is the basic of the vector. Actually, vector is what? Vector is advanced version of coordinate geometry. See, in coordinate geometry, you can define a point by this ordered pair x comma y. Now, in coordinate, we have some shortcoming. We cannot multiply 2 points in coordinate. But in vector, we have one extra facilities, means one step ahead than coordinate geometry. So the same thing will be expressed by xi, here it is a 2-dimensional vector, plus yj. Ij unit vector, it will be taught in later. Now its advanced version is matrix. Its advanced version is matrix. Matrix also consists 3 criteria, that addition, subtraction and product. But division is introduced in complex number. Okay. So each system defines the point, position of a point, but step by step it became advanced. So coordinate, vector, matrix, complex number, superset of all set. Now in coordinate geometry, any point is measured with respect to origin, means the point which is the junction of x and y axis. But in same thing will be done in case of vector. See, it is called position vector. It is called position vector. Okay. Vector will be measured with respect to origin. So it is called position vector. Position vector. That means suppose there is a point like this P. What is P? P is actually any point in vector space. It is measured with respect to O. OP. P means OP. It is measured with respect to origin. So this is called position vector of P. Position vector of P. Now, what about resultant vector? See, let us draw one triangle. Give the arrow sign like this. Okay. Let vector AB is represented by the vector A, vector BC represented by the vector B. Now, its resultant vector AC means resultant vector, that is AB plus BC. That means AB is A, BC is B. That means A plus B. Okay, AC is A plus B. That is called resultant vector. Okay. Now, what about the triangle law? Or you see, triangle law. Suppose there is a triangle like this. Give the sign. What is meant by that? A particle has initial position A. Now it moves displaced from A to B. I will represent it by AB with arrow sign. Then B to C. Then C to A. That means the final and initial position coincides. It is called zero vector. Its vector displacement is zero. Initial and final position matched or coincide. That is called triangle law. Okay. Now, AB plus BC will be minus CA if I change the sign of one of the vector out of these three. So what about minus CA? Few minutes back we got AB and BA are same by magnitude, but they are differed by a minus sign. So I can write AC. That gives us AC is equal to AB plus BC, resultant vector. AC plus AB plus BC using the triangle law. Which refers the position vector. Okay. Now, let us take in a plane, let us take 2 points. One point is measured with respect to origin, another point also with respect to origin. Give the arrow sign. Okay. Now, if I follow the triangle law, I will get OP, PQ, QO is equal to 0. Okay. OP, PQ, QO 0. Therefore, you do one thing, you keep PQ in left hand side, and the other parts, other two vector will be shifted to right hand side. Now instead of QO, as we are already aware that AB is equal to minus BA, therefore instead of minus QO, I can write OQ. So what conclusion we can draw? PQ vector can be expressed as the difference of two vectors which join the origin and the final position, final minus origin and initial. See, OQ minus OP is PQ. Okay, keeping parity, we can split the vectors in this way with respect to origin. OP minus OA, final minus initial, like XY vector, I can write OI minus OX. So if you express the vector as the difference of two other vectors which is measured with respect to origins, means position vector, then you will not be confused in putting the arrow sign. Students get confused where to put what arrow sign and what direction to be denoted. So if I memorize in this way that vector xy is final minus initial position with respect to the origin, then it will be an easy task for us to understand what to put the arrow sign in which direction. Hope you understood. Now, how to find the angle between two vectors? See, to find that, we have to take two vectors which are coming from a common point, or you can say diverge from a common point or converge to a common point. Okay, it is diverge from a common point or converge to a common point. So these are called, this is called actually co-initial vectors, means that their initial position are same. This is co-terminal vectors, co-terminal vectors. So they converge to a point. Understand? This is co-initial vectors, co-terminal vectors. Okay. Now, how to find the angle between two vectors? See, if two vectors are co-initial like this or co-terminal like this, then we can find the angle between them, included by them, this angle or this angle. Okay. Otherwise, what happens? Otherwise, see, otherwise, you do one thing. See, this is a vector. If you give the arrow sign in this direction, then suppose this is A, B and C. And if you are asked to detect what is the angle between AB and BC, suppose this angle is theta, you are asked to detect what is the angle between AB and AC, AB and BC. What is the angle? See, is it theta? No. Why? Because they are not co-initial or they are not co-terminal. So I have to make them either co-initial or co-terminal. So to make it co-terminal, you produce it like this. Produce it. So the angle which was seen to us, the included angle, is not now to be considered. I will consider this angle will be the included angle. Why? Because once I produce it, then I have got two co-initial vectors. So that angle could have been considered. Understand? So angle between AB and BC is pi minus theta. Angle between angle between AB and BC is pi minus theta. Okay. So this is the way you can find the angle between two vectors. Hope you could follow. Now suppose this is a vector OA. Let arrow sign is indicates that it moves from O to A. Let OA vector refers vector A. Now, if I multiply both sides by a scalar value, means if vector is multiplied by the scalar, say new vector will be born, and that is called collinear or co-basal or parallel or anti-parallel vectors. Okay, lambda A is collinear, co-basal, parallel or anti-parallel vector of vector A. Okay, of vector A. This is called collinearity, condition of collinearity. Therefore, if you get a vector like this, then two vectors A and B will be collinear, parallel or anti-parallel or anti-parallel. Okay, hope you could follow. Now the question is, what is parallel vectors? See, if two vectors are there, but they are not meeting with each other and their direction are same, it is called, they are called parallel vectors. Okay, and if there is two non-intersecting vector but direction different, that is called anti-parallel vectors. That is called anti-parallel vectors. Hope up to this stage it is okay. Now, parallel vectors is what? Anti-parallel vectors is what? Now, it has been clear to you. Now we will consider direction cosine or ratio of, three-dimension figure like cube, cuboid. Direction cosine. Direction cosine. See, let us draw one cube like this. Okay. And that point is P. Understand? That point is P. If I join, I will get what? The leading diagonal. Leading diagonal of a cube. You are taught that it's in mensuration. Now, OP vector makes angle alpha, beta and gamma. Means this angle is alpha, this angle is beta and that angle is gamma with x, y and z axis. Okay, better you label it by x axis, y axis, z axis. Okay, OP makes alpha, beta, gamma with x, y and z axis. Okay. Now you join this. Let us take this point as A, this point as B, this point as C. OA, magnitude is A. OB, magnitude is B. And OC, magnitude is C. Now, cos alpha, we know base by hypotenuse. But here, that it is a 3D figure and we are drawing on a plane surface, means 2D. So, cos alpha is base by hypotenuse, means here diagonal. Cos alpha is base OA. OA's magnitude is A. What is the diagonal? If this is, you see, if this point is A0, 0, this point is 0, B, 0, and that point is C, 0, 0, C, then cos alpha will be what? A by magnitude of OP. What is OP? By vector, by coordinate, OP is what? A comma B comma C, and by vector C along with x-axis I will consider as I unit vector, along y-axis J, along z-axis K. So I can write it AI BJ CK. Unit vector are denoted by IJK, where I, J, K are unit vectors along X, Y and Z axis. Cos alpha A by mod OP. Now cos beta. Cos beta this triangle. Cos beta. What is base? B. Magnitude OP. Magnitude OP means diagonal. Cos gamma. C by root A square plus B square plus C. So cos alpha, cos beta, cos gamma. Cos alpha is denoted by L, cos beta by M, cos gamma by N. This element, what is this element? It will be called direction cosine. Direction cosine of a vector P, okay, which makes alpha, beta, gamma angle with coordinate axis. Therefore, L, M, N are called direction cosine direction cosine. From cos we get cosine. It actually implies the direction of OP. Okay. Now element called direction cosine. Direction cosine of OP, which makes alpha, beta, gamma angle with coordinate axis. So that is called direction cosine. See, we have got L, root of a square, b square, c square plus m, root of a square plus b square plus c square. Okay, and n, root of a square plus b square plus c square. These are direction cosine. So we can rewrite this in this way: L by A m by B and n by C. Okay, L by A, m by B, n by C. So each of these ratio is equal to a common value that gives us L by A, m by B, n by C. Here element are with ratio are in ratio with ABC. So these ABC are called direction ratio. Direction ratio. Okay. Well, I hope you understood what is direction ratio and cosine. You see, you square and add all this. You see, root will be removed. So that will give us so sum of the square of the direction cosine is 1. So sum of the squares of direction cosines is 1 always. Hope you understood. Now we can discuss about the